Hi everyone, myself Ganavai. In this video I am going to explain one of the named reaction called benzoin condensation. Okay, benzoin condensation. Okay, this comes under only in aldehydes and ketones. Okay, you know right what is the example for aldehydes and ketones. Okay, and this benzoin condensation takes place usually in aromatic aldehydes. Okay, in aromatic aldehydes which is lack of alpha hydrogen. Okay, in many examples in other reaction you may heard in aldol condensation etc., which in that reaction those aldehydes and ketone must contain alpha hydrogen, but in the case of benzoin condensation takes place usually in the aromatic aldehydes, and which aldehydes are lack of alpha hydrogen. Okay, we'll see. I'll give an example while studying the reaction. What do you mean by aromatic aldehyde which is lack of alpha hydrogen? Okay, that is, example is benzaldehyde. You can see in benzaldehyde where carbonyl group, that is aldehyde group, which is attached to the aromatic ring. So carbon atom which is next to the carbonyl group is called alpha carbon, where in the alpha carbon there is no hydrogen. That's why that is the example for aldehyde which is lack of alpha hydrogen. Okay, this benzoin condensation takes place in the aromatic aldehyde which is lack of alpha hydrogen. Okay, now we'll see what is benzoin condensation. Okay, in this reaction which is once again involves the self addition or self condensation of aromatic aldehyde, as I said, which is lack of alpha hydrogen. So there is once again reaction takes place with the aldehydes, two aldehydes which is lack of alpha hydrogen going to addition are going to react in presence of aqueous alcoholic potassium cyanide. Okay, in presence of aqueous alcoholic potassium cyanide to give alpha hydroxy ketones. That means in alpha position there is a hydroxy group. Okay, next to the carbonyl group, that is a carbon that is referred as alpha carbon, to that hydroxy group going to substitute. That is about this reaction. Now you are more clear with the, you will come to know by the example. Okay, that is benzaldehyde. As I said, you can see there is no alpha hydrogen here. This one molecule of benzaldehyde going to react with another molecule of benzaldehyde in presence of alcoholic, here ethanol is used, in presence of alcoholic potassium cyanide to give alpha hydroxy ketones. Okay, here you can see this is a carbonyl group, next to that is alpha carbon. At alpha position there is a hydroxy group, that's why this is alpha hydroxy ketones. Okay, both the groups are substituted by other than the hydrogen, that's why it is a ketone, not an aldehyde. And name of this compound is 2-hydroxy, or you can also mention alpha hydroxy, and 1,2 diphenyl ethanone. Okay, since you have 2 carbon, that's why ethanone. I will repeat the name, that is 2-hydroxy 1,2 phenyl ethanone, and common name of this compound is benzoin. That's why name is given benzoin condensation. For this reaction product is benzoin. You can easily remember this product as well as this reaction. Okay, and now we will see the mechanism of this reaction. We will see the mechanism. Then reaction involves the following step. Okay, we will study one by one. And there are 3 steps. In first step, formation of carbanion by the nucleophile attack of cyanide to the carbonyl group of benzaldehyde. That means in the first step, generation of carbanion takes place. That is by the attack of cyano group. As we see, that is, this reaction takes place in presence of potassium cyanide, where cyano group attack to the carbonyl carbon of your one of the benzaldehyde. You can see this is the benzaldehyde. To this benzaldehyde, your cyano group attacks to the carbonyl carbon, because this is a electron deficient. This nucleophile attack to the carbonyl carbon. As a result, shifting of pi bond takes place and we will get the negative charge on the oxygen. Negative charge on the oxygen. Okay. Then this is not the stable compound. Okay. This is not the stable compound, because this negatively charged oxygen abstract the proton from the same molecule. Okay. This negatively charged oxygen abstract the proton from the same molecule. That is because here whatever the cyano group attached is highly electron rich or highly electron withdrawing. Okay, it withdraws the electron from this carbon. Okay, when it withdraws the electron from this carbon also pulls the electron from the proton. As a result, this negative charge oxygen can easily takes up this proton. That's why this shifting of proton takes place from carbon to hydrogen. Okay, carbon to hydrogen. Now this is the generated carbanion. Okay, in first step, formation of carbanion takes place. This is your carbanion. Okay, in second step, attack of carbanion. Whatever generated carbanion in first step, okay, which attack to the second molecule of your aldehyde. So we know that in this reaction there are two benzaldehyde. First is already generated, right? It is generated carbanion that going to attack to second molecule of your benzaldehyde. Okay, we will see the reaction. Okay, so this is generated anion in the first step, that is going to attack to the another molecule of benzaldehyde. Okay, another molecule of aldehyde. You can see the arrow marks. Okay, in this way it attacks to the carbonyl carbon. When it attacks, once again shifting of pi bond takes place and negative charge on the oxygen forms. Okay, shifting of negative charge takes place. You can see this formation of addition product takes place. That means two molecules going to add. Okay, in this way formation of negative charge takes place on the oxygen. Okay, now we will see the third step. Okay, in second step, addition takes place. Addition of one aldehyde with another aldehyde. Okay, you have the negative charge on the oxygen. That negatively charged oxygen. Okay, proton transfer. Here there is a proton. Okay, you can see here proton transfer takes place in first step. Here in the third step, there are two steps are involved in the third step. Okay, here this negatively charged oxygen takes up the proton from the neighboring hydroxy group. Okay, you can see here arrow mark, that proton shift takes place from this oxygen to this oxygen. Okay, here hydroxy group formation takes place. Then this negatively charged oxygen shift to form a pi bond. This negatively charged oxygen shift to form a pi bond. When it shifts, cyano group going to remove. Cyano group going to remove. Okay, removal of cyanide group. Okay, as a result, you will get the benzoin. You will get the benzoin, that is alpha hydroxy ketones. Okay, alpha hydroxy ketones. This is your product. Now, once again, we will summarize the reaction benzoin condensation. So, benzoin condensation takes place usually in the aromatic aldehydes, which is lack of alpha hydrogen, where two molecules of benzaldehyde undergo self-condensation in presence of alcoholic potassium cyanide to give a product called benzoin or alpha hydroxy ketone. We already seen the example. And mechanism: in the first step, generation of carbanion takes place by the attack of cyanide group. Okay, first step, generation of carbanion, and the second step is attack of carbanion to the second aldehyde, that is to second benzaldehyde of the carbonyl group. Okay, and their addition takes place. Okay, when it attack, that carbanion attack to the oxygen, another molecule of benzaldehyde, addition takes place and formation of negative charge in one of the oxygen takes place. In the third step, proton transfer and loss of cyanide group. Okay, proton transfer and loss of cyanide group takes place. Finally, we will get the product called benzoin. This is about the benzoin condensation. Okay, now we will see the field application. There are many applications for this reaction. We will see only one or two. Okay, application. So, anisaldehyde and paratolaldehyde. You can write the structure of anisaldehyde and paratolaldehyde. I hope. Okay, those gives the corresponding alpha hydroxy ketones. Okay, when you do the reaction, you can write the reaction if you know the mechanism. If you given any other compound instead of benzaldehyde, okay, if you given anisaldehyde, you can write the reaction as well as corresponding product. Those gives the corresponding alpha hydroxy ketones. Similarly, perfurol, which gives the furan. Okay, those products are utilized in the biological and medical area. Okay, those are utilized in the biological and medical area. This is about the benzoin condensation. Thank you.